Hi students, let's look at this question which is on techniques of integration taken from a 2005 of the H2 Math A-level paper, I believe. So the indefinite integral of px, px is the polynomial of in x, right? Okay, it's denoted by I. Find I, the integral. Okay, this integral here when px is x squared. So given that I is actually going by px, then this is x cubed plus 1 dx, right? Okay, so this case if px is equals to I square, so I, the integral, will just be x square over x cubed plus 1 dx, right? So this is pretty okay. Now this we could just use substitution method, or we can just use the f prime of x method. So we just put a 1/3 in front. This will just be ln. Okay, so or you can just let u be u equals to x cubed plus 1. So du, so 3x squared. So we cancel this. You get this case will be 1/3 1 over u du. So this is ln u, right? So same with this. This is 1/3 ln x cubed plus 1 plus c. Okay, I think the first part is pretty okay. So you can use this the f prime fx, or you can just use the u substitution. Doesn't matter, cancelling method. So the next part will be part 2, writing x cubed in terms of this, right? Where a and b are constant, find the integral when px is x squared minus x plus 1. Okay, let's look at that. So this case here, now we are given that px is equals to x squared minus x squared plus 1. So the what do you call it? The numerator becomes this, right? Then the denominator, actually what it says is put it in fraction. So very likely you just have to use partial fraction, right, to actually find the integral there. Yeah, I think that's about it. So what we're gonna do is actually just you could do a long division, or you can just compare coefficients. So I'm just gonna compare coefficients. Done here. So by comparing the coefficient, by comparing the constants, b is equals to 1. So this is 1, right? So the constant over here will just be b times multiplied by 1. So b is 1. Then of course I could compare the coefficient of x, right? The coefficient of x on the left hand side is 0 because there's a 0, 0 here. Then I'm gonna just multiply it with 1 multiplied by a, then b multiplied by x. Okay, so that will be equals to a plus b. So means this a will just be minus 1. Or we could also just do a long division. Okay, it doesn't matter. So that's that. We're just gonna replace the denominator with factorized form. So from here, shouldn't be an issue. So it's x plus 1. So be x squared minus x plus 1 dx. Great. Okay, so this case here, what we get here is pretty okay. What we can do is actually just cancel this out because these are both same factor here. So x plus 1 dx. So this is just ln, just turned out to be our secondary school integral. So this shouldn't be an issue. This is a linear, so ln x plus 1 plus c. Pretty good question though. So let's look at the part B. Part B, now we have got b is x plus 1. I think shouldn't be an issue here. Same thing, use the part B when px equals to x plus 1. So the integral will just becomes I. So it'll be px, right? So just integral of x plus 1 over x plus 1 x squared minus x plus 1 dx. Okay, so from here, this case we cancel the x plus 1 instead. So what I'll get is actually 1 over x squared minus x plus 1 dx. Now this case here, what you need to understand is that the bottom is quadratic, the numerator is constant, right? You have to use MF26. So in order to use MF26, what we need to do is just complete the square for the denominator. So I'm going to side quest a bit. So x squared minus x plus 1, x minus half square, minus of half square plus 1. There will be x minus half square, minus 1/4. 1 minus 1/4 will be 3/4 here. So there you go. This is my completed square form. From here, what I'll get is 1 over x minus half square plus 3/4 dx. Then we're gonna get so this case I'm just gonna square root and square, right? Here what we get is tangent inverse. Use MF27. or MF26. Okay, so this is square root 3 over 2 square dx. So in MF, in the formula booklet, we know that this is 1 over a, tangent inverse x over a. So 1 over a, here 1 over a, tangent inverse x over a. So this integral here, this is under MF 20, what do you call it, 27. So tangent inverse x minus half over square root 3 over 2. Okay, so plus c. So this shouldn't be an issue. What happens is we just multiply by 2 on top and multiply by 2 below to get rid of a denominator. And the reciprocal of the this over here will be just 2 root 3 tangent inverse, then 2x minus 1 over root 3 plus c. Okay, that's it. So I do this question here for part B. Then we look at part 3. Okay, by using the result in 1 and 2, part 1 or 1 and 2, okay, great, 1 and 2, I'll find I when px is equals to 1. Okay, so let's do that. We're gonna do that. So you know when px equals to 1, the integral becomes 1 over x cubed plus 1 dx. Alright. And after which we could also write this as the what you call it, we just factorize the denominator, which is x plus 1 x squared. So x squared x cubed plus 1 will just be here you go, minus x plus 1. Okay, we just do this first. So what do we do from here is pretty okay. What you need to do is just split this up into partial fraction. So a over x, it was always 1 degree, the numerator will be 1 degree less than the denominator. So this is bx plus c x squared minus x plus 1 dx. Okay, so that's what you do. Then we just find out what is a, b, and c. So this one, we're just gonna side quest a bit. So I'm gonna just I know that actually it's just a speed up method. Okay, it's just a speed up method. So from here we know that 1 is equals to a plus b x plus c. Oh, sorry, just 1 a multiply, just make it common denominator, x squared minus x plus 1 plus bx plus c x plus 1. Okay, so essentially what I'm doing is just doing this. I'll just write this down. X squared minus x plus 1 is equals to a x squared. If I make it a common denominator, right, so plus b x plus c multiplied by x plus 1 over x plus 1 x squared minus x plus 1. Okay, that's it. So this is what we do. Then what we can do next is just try and solve for a and b. I think what we could do is maybe compare the coefficient or compare the constant. Is it so? Let x be 1, 2, minus 1. This will be 0. Minus 1. Let x equals to minus 1 equals to a 1 plus 1 plus 1. This will be 0. Of course, minus 1, this will be entire thing will be, so 3a is equals to 1. So this will give us a equals to 1/3. Okay, so I'm just side questing. This is it. Then we do the same thing for let x equals to 0 maybe. 0 will be good. Yeah, so 1 equals to 1/3. A is 0 minus 0 plus 1 plus c 1. So this will give us c equals to 2/3. Great. So c will be 2/3. Then after which we just substitute any value, x equals to 1 maybe. Okay, so 1 is equals to a, so it's 1/3. 1 minus 1 plus 1 plus b plus 2/3 for the c, and this is 1 plus 1. Then we're gonna find for our b there. They'll give us a solid minus 1/3. Okay, there you go. So this case here, what we get is then I'm gonna just replace all the a, b, c in. So a will be 1/3 x plus 1. Then b will be negative 1/3 x. Then that will be plus 2 plus 2/3 c dx. Done. So what I'm gonna do is I'm gonna just simplify this. We could just separate this out, make it look nicer. X plus one. Then the second integral, I'm gonna factorize the negative 1/3 out. Okay, or maybe I just leave it as okay. I will just put a negative 1/3 out. There will be x minus 2 over x squared minus x plus 1. Okay. Now then we could split this up because previously we've done oh, this is x plus 1, right? Then over here was is x squared minus x plus 1. X squared minus x plus 1. Then we could split this up again. This second guy. So this will just be 1/3 ln x plus 1, right? We already done this. So this minus 1/3. Because to do this, what we need to do is we differentiate this bottom. It will be x 2x minus 1. So we split this up using the split up method. We have x minus 1, okay, minus 1 over here. So the minus 1 will be minus 2. This will be the fastest way to do that. Then this guy could be split again. We 1/3 ln x plus 1 minus 1/3 x minus 1 over x squared minus 2x plus 1. Remember, this careful, you multiply in, you'll be a positive, okay? So this one, I think a lot of students would have a mistake, careless mistake here. Then this will be integration of x squared minus x plus 1 dx. This guy is from the previous part of this, right? We get this. So I'm just going to copy this integral here. Yep, that's that. Then this will be 1/3 ln x plus 1. This will be this is just cancelling method. What I will get is this is my u. Okay, I could let this be my u because du will just be 2x minus 2. Okay, so this will be so 2x minus 1. So I split it wrongly. Sorry, yeah, I split it wrongly. So this part here is wrong. My careless mistake. So you have to split it. So let me just split this up. Okay, I split it wrongly because the denominator is 2x minus 1, not 2x. So this case of x minus 2 equals to p, 2x minus 1 plus q. Okay, so differentiate so p is equals to 1, p is equals to half, then minus p plus q, the constant will be this. So q equals to minus half plus minus 2 plus half, which is minus 3 over 2. Okay, the idea is you split it up. So what I do is this over here, this will be the derivative of this denominator. Okay, so you split up p something. So this case will be half 2x minus 1 minus 3 over 2. Okay, so here shouldn't be an issue. Ln, then split it up minus distribute it in 6 2x minus 1. Just be careful. Plus 1 3 over 2. Yeah. Okay. So what I did was I just distribute this in. I'll get this. Distribute this in. I'll get this. Okay, but this is negative, negative, positive. Okay. So then this will be our cancelling method, du dx. Plus 1. 2x minus 1 over u du. 2x minus 1. So your u is this bottom guy. So you just cancel this out. This is ln u, obviously. So let u equals to x squared minus x plus 1. Okay. Then this will be half. Then this will just copy from previously, which is actually just 2/3. This guy here, because that's the integral that we get. There you go. So what you do is this is from the previous part. So once done, you get 1 over 6 here. 1/3 ln x plus 1 minus 6 ln x squared minus x plus 1 plus 1 over 1/3 tangent inverse 2x minus 1 over 3 plus c. Okay, so that's how I do this question here proficiently. If you have any questions, do let me know and I'll see you in the next question.